Today we're going to be learning lesson 7.3, which is just solving equations with multiplication and division. So previously we have learned how to solve equations using addition and subtraction. Today is just taking it just a little bit harder with that multiplication and division. Okay, but we do it the exact same way that we solved equations with addition and subtraction. The first skill we're going to talk about, just like before, was checking solutions. So telling whether a value of x that we're given is true for an equation. Okay, so I'm going to apologize ahead of time. My pen that I normally use to take notes is not working with my computer, so I'm going to have to use my mouse. So there might be a lot of clicking. I apologize. And then my handwriting might not even be, it might even be sloppier than normal, so I'm sorry. But anyways, going ahead. Equations may be true for some values and false for others, or not true. Oh my gosh. I'm sorry. Okay, so here we're given some values for x and we're given an equation. We want to know, are both sides equal, meaning that is this a solution to the equation? Okay, our equation is x over 2 equals 8. Now first we have to think about what operation is that fraction bar. Okay, a fraction bar is the same thing as division. Okay, so we're going to be plugging in first 10 for our x. So instead of writing x over 2, we are going to write 10 over 2 equals 8. And 10 divided by 2, because the fraction bar is the same as division, 10 divided by 2 is 5. Is 5 equal to 8? That's going to be no. Okay, same idea for 12. Now we're going to check to see if 12 is true. So we're going to have 12 over 2 equals 8. And is 12 divided by 2 equal to 8? No, 12 divided by 2 is 6, which is not equal to 8. Last but not least, we're going to check for 16. So we're going to have 16 over 2 is equal to 8. And 16 divided by 2 is equal to 8. So this would be a solution. Yes. Okay, so just checking for solutions. We're going to do some examples down here that are just getting a little bit harder. Okay, so now we're going to plug in m, because it says m equals 5, to this equation. 3 times m equals 12. To see if 5 is a solution. Now when we have a 3 and an m next to each other, remember that's multiplication, we just don't write the symbol. But when we plug in that 5, we need to make sure to write a multiplication symbol or put it in parentheses so that it does not turn into a 35, because that would not be good. So we have 3 times 5 equals 12. 15 equals 12, that is not true. So no, that is not a solution. Right. Same idea over here. We have y divided by, fraction bars are divide, 5 plus 1 equals 3. Same thing, we're going to plug in our 10 for y to see if it's true. So we're going to do 10 divided by 5 plus 1 equal to 3. First, we're going to do order of operations, so division before addition. 10 divided by 5 is 2 plus 1 equals 3, and 2 plus 1 is 3. So yes, this is a solution. I apologize for my handwriting. This is brutal. Okay, let's move on to solving equations. Okay, when you multiply, I'm going to abbreviate this for the sake of you not having to read my handwriting any more than you need to. So when you multiply or divide, I would write out the whole words if I were you. The same number to both sides of an equation. I'm going to try this with my finger. That's a little better. To both sides of an equation, the two sides remain equal. Okay. So just like when we added or subtracted something to both sides of the equation, it remained the same as long as we added the same number or subtracted the same number to both sides. Same idea here. Okay, if we do 8 times 2, and when we solve equations, we show multiplication with parentheses, because if we start putting like dots or stars, it just gets confusing with like decimals and things like that. So we always use parentheses. So you do parentheses 2 to each side, draw a line down our equals. And 8 times 2 over here is 16. 8 times 2 over here equals 16. We can prove that those are staying the same. Same idea for B, except for now we're going to try dividing. So we're going to divide by 2. When we solve equations, we show division with a fraction bar. It's just what we have to do. Okay, we do have to show our work that way. 10 divided by 2 is 5. 10 divided by 2 is 5. It is staying the same. So we're just proving that what I told you up here is true, basically. Okay, which we already knew that. So to solve an equation for a variable, you must use the opposite or inverse operation to get the variable all by itself on one side. And remember that variable is a very fancy word of saying letter. Okay, so we just want to get that x by itself, or that m by itself, or that y by itself. Okay, so just like addition and subtraction, they have multiplication and division have inverse operations, meaning that it undoes multiplication or it undoes division. Okay, so the opposite operation of multiplication, I'm sure you guessed it, is division. And the opposite of division is multiplication. Multiplication. Struggling right now. Okay. All right. So we're going to use the inverse operations to solve a problem that has multiplication. So we'd use division to solve a problem that has multiplication, and we'd use multiplication to solve a problem that has division. Just like with addition and subtraction, we always had to do like the opposite of what was given to us in the problem. Okay, so here we have 2x. And remember what we are doing with that 2 and that x. 2 times x equals 20. Okay, so our very first step to solve an equation with multiplication and division is determine which operation is being used, which I kind of just did for you. I'm working ahead. 2 times x, so we're using multiplication. Okay, then we're going to cancel out that 2 times by using that inverse or opposite operation, okay, with the same number that we're multiplying by. So whatever we're multiplying by is what we're going to divide by. Whatever we're dividing by in the problem, we're going to multiply by. Okay, so notice how in the problem we're multiplying by 2. So to solve it, we would divide by 2 because we want that 2 to cancel out. We are going to make sure to show all of our work. Make sure we draw a line down that equal sign to make sure that we are doing the same thing to both sides. That's super important so that we keep the equation equal on both sides. Okay. Now remember, we are doing 2 times x. So to undo that, we are going to do division. We show division with a fraction bar. That is non-negotiable. You need to use a division or a fraction bar for division when you're showing your work. Okay. So 2x divided by 2, 20 divided by 2. We're doing the same thing to both sides to keep it equal. Now 2 divided by 2 is 1. Okay, so we'd be left with 1x, and 1x is just the same exact thing as x. Okay, so that's how we're canceling out to get it to be x. And 20 divided by 2 is 10. So for this example up here, x would be equal to 10. All right, I want you to watch me do at least one more example before you go and try to do some on your own. Maybe the next 2 examples, and then I'll have you go and do some on your own. Okay, so we have w fraction bar 4, so w over 4 equals 12. Now, the first step was to determine what operation is being used, so the operation in the problem is division. So the way we undo that is multiplication. Okay, remember we show multiplication, and this also is non-negotiable, meaning that you cannot choose to do it another way. Okay, you will get points off. That is a very brutal 4, sorry. I'll redo that. Okay. There we go. So we show parentheses 4 on both sides. Okay. Multiplying both sides, that equal sign by 4. Now 4 divided by 4, or divide by 4 times by 4 cancels out to be a 1, and w divided by 1 is just w. So on the left side we're left with w equals, and then we do 12 times 4, which is 48. So we would get w equals 48. Okay. Now at this point, if you feel comfortable to pause the video and do some examples on your own, absolutely go for it. If you want to watch me do a couple more examples, that's totally fine too. I would definitely ask that by maybe problem 3 or 4 that you are doing some of these on your own though. Okay, so make sure we are challenging ourselves, pausing that video, and trying to do some of these all by ourselves, and then just resuming the video to check. All right, so here we have 5 times b in the problem. So to undo 5 times b, we divide by 5. We show division with a fraction bar. Okay, I'm just going to undo that so that, ooh, what is that? So that doesn't run into the next problem since I don't have an eraser today. 5 divided by 5 would cancel out because that's just 1, and 1 times b is just b. So we're left with b equals, and then we would do 65 divided by 5, and we would want to do long division for that on the side. Since I'm struggling to write, that would be a huge pain in the butt. So I'm not going to show that long division, but that is what we should be doing to solve it. So if you need to pause the video to do your long division to see if you can get this correct, that is what I would recommend. Okay, so 65 divided by 5, we do our long division, and we would get 13. B equals 13. Okay, number 3. We have a over 8. So if you have not yet paused the video, now we've done an example of every single type. So I would like you to pause it, try some of these on your own, and then resume it. But if you've already done that, then I'll stop talking. So we're going to multiply both sides by 8 since we are dividing a by 8 and we want to get a all by itself. We have to undo whatever's next to it, which is divide 8 by multiplying by 8. We get a equals 6 times 8, which is 48. Last but not least, we have 81 equals 9. Sorry, not last but not least. We still have 3 more examples. 81 equals 9 times r. We would divide by 9. Our 9s would cancel out. We're left with r equals divide by 9. 81 divided by 9 is 9. All right, 5 and 6 look difficult. Yes, they do, okay? But they are just the same exact problems as above, just with fractions, okay? So it's just like a little bit difficult, more difficult, but not really. So we are dividing by 1/2, so to undo that, we multiply by 1/2. Multiply 6 by 1/2. We draw our line. So that divide 1/2 and multiply 1/2 cancels out. We're left with x equals, and here we have to actually do some math, okay? So we change 6 into 6 over 1 so that we can multiply the fractions. We're multiplying it by 1/2. We get x equals, and when we multiply fractions, remember, we haven't done this in a while, we just multiply across the top, across the bottom. So we get 6 times 1 is 6. 1 times 2 is 2. However, now we have to simplify this because this is a nice fraction, so it reduces down just to a number. So we get x equals 3, because 6 divided by 2 is 3, or 2 goes into 6 3 whole times. Just a couple more. Here we have 2/7 times x. So to undo that, we divide by 2/7. So divide both sides by 2/7. Divide by 2/7. 2/7 divided by 2/7 is just 1, so we're left with x equals, and we take 6 divided by 2/7. We make 6 a fraction, and we divide it by 2/7. Now remember that really awesome video I showed you guys about dividing fractions? Keep, change, flip. Yeah, so that was awesome. Singing on my half, I apologize for having to put you through that. But we have 6 over 1, we keep, change division to multiplication, and we flip 2 over 7 to 7 over 2. Multiply the top numbers, 6 times 7. I'm going to go off the page, hopefully you have some room here. 42. 2 times 1 is 2. Now 2 can go into 42 an even number of times. Okay, and that is going to be 21. Again, we would want our work a little more organized than this, but because of not having my pen, I have to kind of squish it. Okay. All right, hopefully you're feeling okay by this point. If not, please raise your hand, ask questions. Let me know what you need help with, because I cannot help you if I don't know that you're struggling. Last one. The area of a parallelogram shaped courtyard, so like a grassy area, is 2,730 square feet. We want to know what is the length of this sidewalk. So we want to know what is this length right here. Okay, that gray little sidewalk. First of all, we need to remember what our formula for the area of a parallelogram is. Remember, a parallelogram is a rectangle. No. A rectangle is a parallelogram. That's right. Rectangle is a parallelogram, so they have the same formulas. Area equals base times height. Okay, now we're going to substitute in what we know. Okay, we know that the area is 2,730. So instead of writing the A for area, we are going to write the number that it represents, which is 2,730 equals. The base is like the bottom of a parallelogram, and if we flip this parallelogram over, the base would be like the outer piece, which is 65. And we don't know what that height is. Remember that height is straight up and down connecting the two bases, which would be that sidewalk. All right. Now that we have our equation written, we want to solve it. Okay, we want to get this h by itself. So we have to undo 65 times h. So we think to ourselves, how do we undo 65 times h? Well, that's multiplication. So I undo multiplication with division. So I'm going to divide by 65. Divide by 65. I did not need to write that there, sorry. Okay, 65 divided by 65 is just 1. 1 times h is just h, so we're left with h equals. Now we have to do some long division here because this is not mental math. Okay, so we have 27, and bear with me if this is sloppy because it's so small, divided by 65. So we would guess and check to see how many times 65 can go into 2. Well, that's 0. How many times 65 can go into 27? That's also 0. How many times can 65 go into 273? We'd have to guess and check. So you could do that on the side of your paper. Just make sure not to clutter up where we're showing our work for that equation. And that's going to be 4 times. Okay, because 65 times 4 is 260. So we would subtract 260 and be left with 100. Bring down that 0, 130. Okay, then we ask ourselves how many times can 65 go into 130? Well, I know 60 goes into 130 twice because 60 times 2 is 120. So I'm going to guess that it's 2. So on the side of my paper, I would do 65 times 2 to see if that's right. And it is. 65 times 2 is 130 exactly. You get a 0 remainder, you're done, and your answer would be 42. We need a label. The length of that sidewalk would be 42 feet. All right, and that's it. Main idea here for this lesson is that you have to do the opposite of what you're doing in the problem. I always want you to make that mental thought or mental note of what am I doing in the problem? How am I going to undo that? Okay, because the biggest mistake that I see, let me just erase some of this right here, is a problem like this, number 4. Okay, where I see students minusing or subtracting 9 here when we're not adding 9 to r. So we can't subtract 9, that's not going to help us. Okay, we need to be dividing because we're multiplying in the problem. So I always want you to make that little mental thought of, okay, what am I doing in the problem? And then how do I undo that? And that's going to solve, honestly, most of your mistakes that you'll make. Okay, which making mistakes is good. That's how we learn. All right, so main idea is just that we have to do the opposite of what's in the problem and mentally go through that process while you are doing these equations. Show all your work. That's important too. All right. Bye. Bye.